All right, we are talking about correlation coefficients. This is target 8C. All right, so let's start off with scatter plots. There are a few different types of scatter plots. There is scatter plot showing a positive correlation, a negative correlation, no correlation, and a nonlinear correlation. So you can see, these points here are kind of like tight together, but they don't form anything resembling a line. For no correlation, these are kind of all over the place. They don't really kind of form anything. Negative correlation, if you were to draw a line of best fit, it would kind of go like that, and it would be negative, just like it basically refers to the slope. Okay, so a negative correlation shows the points kind of tight together, going down from left to right, and a positive correlation would be going up from left to right. All right, so what is a scatter plot? Scatter plot is a graph of a collection of ordered pairs. So all of these points are ordered pairs. It may look like kind of a bunch of dots, but some of the graphs are a general shape or move in a general direction. So again, I could kind of draw a line. Well, that wouldn't be it. I could draw a line that would go through this and kind of represent the data as best as possible. And you saw briefly how to do this on the calculator, and I am going to be going through the steps on how to do that again. All right, so a positive correlation. If the x and y coordinates both increase from left to right, then it's positive. All right, so if you look here, these are increasing. Y is going up as you go to the right, and x is going up as you go to the right. X is always going to go up. It's just, is y going up or is y going down? All right. Positive correlation example. We've got a growth chart for children. All right, so the age of a child versus its height. So this would be the age over on this side. So as the child gets older, or this would be the height, I'm sorry. As the child gets older, their height increases. They get taller. So like at age 1, you see all these numbers, and they're all going up. All right, the age is also all going up. So just by looking at, you can look at the graph, and you can see that it has a general kind of slope to it, or you can look at this and see, well, each time I progress, I'm going up. Okay? And that's what we'd call positive correlation. A negative correlation, though, the x coordinates would be increasing and the y coordinates would be decreasing. So, remember, x gets bigger going this way, so x is always going to get bigger. It's just y starts up high, but then goes low. So that would be a negative correlation. All right? One goes up, one goes down. They're related as opposites. So a negative correlation, a really good example is the value of a car. Okay, as the car gets older, it is worth less. That's pretty much going to be any car that you guys buy. Keep that in mind. All right, so you can see how the value of the car decreases as the years of age increase. All right, so again, that would be a negative correlation. Okay, no correlation. If there's no pattern, the points are kind of like all over the place, then we would say it has no correlation. Okay, this is an example of no correlation. You really can't find a line of best fit here. Okay, so the two would not be related. Okay, a no correlation example, Michael Jordan playing basketball. If you look at the shoe size a baseball player wears and their batting average, you'll find the shoe size doesn't make the player better or worse. Okay, shoe size has nothing to do with batting average. So yeah, about the only good thing we can say about that is he played for the White Sox and not the Cubs. All right, so a strong positive correlation. Look at how all these points are kind of tightly around that line of best fit. That would be a strong positive correlation. Weak, okay, they're still kind of trending upward, but they're a little bit farther away from where that line of best fit would be. Again, strong negative, they're all kind of like tightly around that line. Weak negative, they're spread out quite a bit, but they're still heading down. A moderate would be, they're not quite tight, around the line, but they're not exactly as, all over the place as this one. And then again, no correlation, the dots are just kind of haphazard all over the place. All right, so let's look at example 1. What kind of correlation exists between the variables? Would you say it'd be a strong positive, a weak positive, a strong negative, a weak negative, or zero correlation or no correlation? Well, I think we can agree that from left to right, everything's going up. So we could rule out the negative ones right off the bat. Okay, now if I drew a line of best fit through this, how tight would those points be? I'd have to say it'd be a strong positive correlation because they'd be pretty tight around that line. All right? Okay, what about this one? Okay, we've got the line already drawn in. We can see that there is a correlation, so we can get rid of 0. It's going down from left to right, so we can get rid of the positive one. So we just kind of have to determine, is it strong or is it weak? Well, as you can see, they're kind of out further from the line, so I would say this would be a weak negative correlation. All right, now coming up, this is where I'm going to go over the calculator stuff after this slide here. So once you're done with this, you can kind of fast forward. I wouldn't fast forward all the way, though, because I do talk about something extra. If you didn't write down the calculator stuff, this is your time to watch it and do it. All right, so if you look at the graph, you can see that there's a high positive correlation. These would be tightly around a line between the two sets of data. However, our two sets of data are the jars of strawberry jam sold in New York and the number of CDs sold in Florida. Okay, does this mean that the number of jars of strawberry jam sold in New York was causing an increase in the number of classical music CDs sold in Florida? I don't think so. So again, be careful as to what these are labeled as. If it's something that doesn't make sense that they would be related, okay, there might still be a correlation, but we'll get into that in more detail, but correlation doesn't necessarily mean that they're related. All right, so be careful what you can infer from that. All right, linear regression. This is where the calculator stuff comes in. All right, so if you're given a scatter plot like the one below, what if you want to use the data to estimate relationships or predict future results? That's where you would use a line of best fit and determine linear regression like we did on the calculator. So basically you're going to start off with the home page. Okay, that's the one that looks like a little house. All right, and then you are going to add a new document. Okay, so there's a new document. This is the home page. Okay, then you are going to go to add listen spreadsheet. Okay, so go back to that. So that's basically new document. Okay, and then number 4. Okay, so if we were given this graph here, we want to input the data given. So in your list, you're going to see this would all be blank. Do not write anything here. Do not type here. Okay, so in that grayed out box, don't type anything. The X values, this column here, those are your X values. Okay, so you can label this as X and Y if you want. Just make sure you know which one to go with which. I like to type in what it actually is. So we've got calories, and then you would go through and type in everything that you see. So all the way down to 440. And then we'd go to B. So this is all the way at the top. That's where you type this in. And then you would type in fat and then type in everything in the Y values. Okay, so again, independent variables, dependent variables. Next, you're going to move the cursor, and then you're going to go to anywhere other than where your data is. Okay, you're going to hit menu, and then statistics, which is 4, stat calculations, which is 1, and then linear regression. So if you want to write this shorthand, maybe do menu 4, 1, 3. Okay, so you should definitely have that written down. And then you're going to see something that has X list and Y list. These are the only 2 things you are changing. That's it. Okay, so basically this means, what did you put as your X? What did you put as your Y? Alright, so when you do that, you're going to press to the right, okay, until you get a drop down box. And your drop down box is going to have a list of different things. And it'll probably have like calories, fat. Okay, our X was our calories. So we would highlight calories and then click that OK on there. And then we do the same thing for the Y list. We tab down, so use tab to move. use tab, the tab button, to move around. Alright, so you would tab down to the Y, and again you'd click to the right, and you'd come up with another drop down box, and this time you'd look for fat. And you'd highlight that and click OK, and then you would tab down until you had OK highlighted, and then you'd click OK. Okay, and then you would come up with something like this on your spreadsheet. Should look like this. Alright, remember, M is your slope. B is your y-intercept. The other thing that we are going to use this time around is the correlation coefficient, which is R. So ignore this. You don't need that. Okay, you need M, B, and R. R is the correlation coefficient. Okay. To see the scatter plot in the linear regression, you would hit Control, Doc. So hit Control. Ignore that. Not at the same time. Press Control, then hit Doc, then add data statistics. Okay. You're going to have to, this will all be blank. These could be all over the place. You would move your cursor until you get over to here. And remember, this is your y-axis. Okay. So we would choose fat. Okay. And then you would move your cursor down to where calories was, or where it is right now. And you'd move it down to there. And then you'd click in this box when it pops up. And then you would select calories and click OK. And then you would have this pop up. To add the line of best fit, or the regression line, you hit Menu, and then 4, 6, and 1. So Menu, 4, 6, 1. So Analyze, Regression, and Show Linear MX plus B. Do not do this one. Okay? Do not do A plus BX. Do MX plus B. And when you do that, it'll put the line in there for you, and it'll give you your equation in slope-intercept form. Alright? So again, let's go back to that correlation coefficient. So this is where hopefully people who saw this and wrote down the previous steps are coming back to us. This correlation coefficient here, R, is important. Okay, this number tells you a lot about the relationships between the data that you've input. So, to determine how well your two values are related, you look at the correlation coefficient because it measures the strength and the direction of the linear relationship between the two variables. Okay, this is a formula for it, so be glad you have a graphing calculator because you do not have to use this. Alright, so basically we're going to be looking for how close are we to these two numbers, -1 or +1. Alright, if it's 0, there is no correlation. Okay, the closer you to get, if it's a positive number, it's a positive correlation. If it's a negative number, it's a negative correlation. Alright, a weak correlation would be between -0.5 and +0.5. This area all in here, weak correlation. Your strong correlations are between 0.5 and 1, and -0.5 and -1. Alright, the closer you are to this number, -1 and +1, the stronger the correlation. Alright, so if you take a look at the last example, we had a correlation coefficient of 0.993768, which is right about here. Okay, so that is a very strong correlation. Alright, so we would be able to say that it has a strong correlation. Alright, so let's look at this example here, and then we would use technology to calculate the linear regression. So we'd have hours in the mall and dollars spent. So you'd go through and you put that all in your calculator, figure out your MX or your M, your B, and the correlation coefficient. So when it says calculate the linear regression, that means put in slope-intercept form. Alright? So that's what you're looking to do there. So again, your X list should be hours. Your Y list should be dollars. Okay, when you put in and then you go ahead and click OK, here's your M, here's your B. That's what you're looking for. That negative 2.28 is your slope, and your B, your y-intercept, is 51.078. So we would say y equals negative 2.28025. So put in the whole thing, x plus, because it's a positive number there, 51.078. So do not round. Do not round. All right, do not. Now, when it says compute the correlation coefficient, if you've done all this, you already have it right here. Negative 0.262451. Okay. Now, if we asked if this was a strong correlation, we would have to say no, because that's pretty darn close to zero. All right. It is a negative correlation if there's one there, but I'd say it's a really weak. That would almost be no correlation. And again, you would do menu 4, 1, 3. All right. So again, we're going to look at another example, and this one's got 2 pages. So this next part's going to be example 4 also. So we've got hours studied and grade. So hours and grade. Notice my hours is my x-axis. So when your table is horizontal, x is always the top one, y is always the bottom one. Okay, so you've got hours studied on top and the grade on the bottom. So use the data above to fill in the blanks about what correlation represents in this situation. So as the number of hours studied, this is kind of all over the place, which is why this comes in handy, because we can look and see, well, as the hours studied increases, the grades tend to also increase. So whatever your independent variable is always going to be increases, always. So number of hours studied increases, grade tends to increase as well, which is very true. All right, now if you put all that in the calculator, you could use your calculator to calculate linear regression. So you would come up with this, and again, we're looking at your M, your B, and your R. So our slope would be 5.56637 x. Our y-intercept is 54.5398, so plus 54.5398. And then it asks you to compute the correlation coefficient of the data, which you just look at R, not R squared, and it's 0.921744. So using that, is there a relationship between the hours studied and grades? Is it strong, moderate, or weak? So I would say, since the correlation coefficient is close to 1, the relationship between hours studied and grades is strong. Okay? So where it asks you, is it strong, moderate, or weak? Notice I mentioned it was strong, and then it said explain the reasoning. Because the correlation coefficient is close to 1. That's your explanation. So you've got to have both those parts in there. All right? So FYI, out of everything this unit, this is definitely the toughest target, and you're not going to see this on an assessment until the test. So there's no more quizzes. There's a test, and that's going to be it. So make sure you take really, really good notes on this. And anything you don't understand, you come in and see me for help or ask questions in class. And that is it. Have a good one.